In this video, we're exploring two groundbreaking AI models, Alpha Proteo and Orb, that are reshaping everything from drug discovery to material science. And before we get started, take a second to subscribe and stay ahead of the curve on all the latest AI trends and updates. All right, you know how proteins are like the workhorses of our bodies, right? They do everything from helping our cells grow to keeping our immune systems running smoothly. And of course, they're at the core of pretty much every biological process. But here's the catch. These proteins don't just do their jobs in isolation, they interact with other proteins. Think of it like a key fitting into a lock. One protein binds to another, and that's how all these critical functions happen inside our cells. Now, thanks to things like AlphaFold, we already have a pretty solid understanding of how proteins interact. AlphaFold helps us predict what these interactions look like, which has been huge for science. But here's the kicker. While AlphaFold is awesome at figuring out how proteins connect, it doesn't create new proteins that could manipulate or influence these interactions. And that's where the real magic comes in, guys. Enter Alpha Proteo by Google DeepMind. This is the new AI system we're talking about today. It doesn't just predict interactions, it designs entirely new proteins that can bind to specific target molecules. And why is that important? Well, these designed proteins, also called binders, can speed up all sorts of research, from drug discovery to figuring out how diseases work, to making crops more resistant to pests. Now let's break this down. When you want to create a protein that binds tightly to a target, like say a virus protein that causes C19, it's not easy. Traditional methods are super slow. You have to create binders in the lab, test them, optimize them, then test them again. It's like an endless cycle of trial and error, which, as you can guess, takes forever. But with Alpha Proteo, we're talking about a major shortcut. This AI system has been trained on a ton of protein data. We're talking about data from the Protein Data Bank and more than 100 million predicted structures from AlphaFold. So yeah, it's learned a thing or two about how proteins interact. Now, if you give Alpha Proteo the structure of a target protein and tell it where you want the protein to bind, it can design a binder protein that fits that target almost perfectly. That's like handing it the blueprint for a lock and having it design the perfect key. And it works on all kinds of proteins. Cancer-related proteins, proteins from viruses like SARS-CoV-2, yes, the one involved in the lockdown era, the C19, and even proteins tied to autoimmune diseases. So far, the results are pretty mind-blowing. In fact, Alpha Proteo generated binders for 7 different target proteins, and here's the kicker. They tested these proteins in the lab, and the AI-designed binders worked like a charm. I'm talking about 300 to 300 times better binding strengths than the best existing methods. Insane, right? For example, let's take VEGF-A, which is a protein linked to cancer and diabetes complications. For the first time ever, an AI system, Alpha Proteo, designed a protein binder that successfully binds to VEGF-A. That alone is a huge milestone, and it's not just one-off successes. Let's take another protein, BHRF1, which is a viral protein. In the lab, 88% of Alpha Proteo's candidate binders actually bound to BHRF1 successfully. And get this, Alpha Proteo's binders on average are binding 10 times stronger than any of the current best designs. Now, one of the most hyped targets was the SARS-CoV-2 spike protein, the very same spike that helps the virus get into our cells. And yeah, Alpha Proteo nailed it. Not only did it design binders for this spike protein, but those binders were tested by some top research groups like the Francis Crick Institute, and they confirmed the binders were legit. These binders even managed to block the virus and some of its variants from infecting cells. So we're looking at something that could potentially help in virus prevention. Now, obviously this tech isn't perfect yet. For example, Alpha Proteo couldn't design a successful binder for TNF-A, which is a protein associated with autoimmune diseases like rheumatoid arthritis. But to be fair, TNF-A is known to be a beast in terms of difficulty. The team picked it on purpose to test the limits of the system, so it's not all bad news. In fact, it's a sign that they're pushing the system to improve. And while strong binding is critical, it's just the first step in using these proteins for real-world applications, like drug design. There's still a ton of bioengineering work to do, but Alpha Proteo has already knocked out one of the toughest parts. Now, the team behind Alpha Proteo is working with scientists across the world to make this system even better. and they're thinking responsibly about biosecurity. That means making sure this powerful tech is used for good, like developing treatments and cleaning the environment rather than, any shady stuff. And if you're wondering where this is going, well, they've already teamed up with groups like the Nuclear Threat Initiative to set up best practices. So the tech is evolving, but with caution, which is honestly a relief. Looking ahead, they're also exploring drug design applications with a company called Isomorphic Labs, and they're actively working on improving the algorithms to make the system even stronger and more versatile. And they're not just doing this in a vacuum. They're collaborating with experts in machine learning, biochemistry, and structural biology. So the future of protein design, it's looking pretty exciting. All right, now, there is another thing I'm seriously hyped about, and it's actually a massive breakthrough in AI and material science. We're talking about Orb, the latest and greatest AI model for simulating advanced materials. It's open source, it's blazing fast, and it's leaving big names like Google and Microsoft in the dust. If you're into AI, energy, or just cutting-edge tech, you're gonna love this. So let me break it down for you. Imagine you're a scientist working on materials for, say, better batteries or solar panels, things that are crucial for the energy transition, right? Well, here's the thing. To design these super efficient materials, you need to know exactly what's happening at the atomic level. We're talking about how atoms and molecules are interacting, what makes certain materials conduct energy better, or how you can tweak them to be more efficient. But, and this is the tricky part, actually seeing or simulating what's happening inside these materials is insanely hard. Traditional methods for simulating this stuff, they're slow, costly, and often involve simplifying things so much that you're not even getting an accurate picture. It's like trying to watch a 4K movie on dial-up internet. It's just not happening. And that's where AI comes in, giving us a new way to look at these materials with way more detail without waiting forever. This brings us to Orb, the model we're talking about today. Built by a company called Orbital, Orb is designed to simulate materials at the atomic level faster and more accurately than anything else out there right now. And get this, it's based on a bigger AI model they've been working on internally called Linus. So basically, they've been fine-tuning this thing for a while now, and it's paying off in a huge way. Now, Orb isn't just faster than the competition, it's 5 times faster than the best alternatives for large-scale simulations. That's a huge leap forward. And we're not just talking about beating random models either. Orb is outperforming Google's and Microsoft's models when it comes to accuracy and speed. And here's where things get even more exciting. They've open-sourced it. Yup. It's free for non-commercial uses and startups, so anyone looking to develop new materials can jump in and use this tech. You can even go to their GitHub right now and check out the full technical breakdown. Now, let me pause here for a second to explain why this is so important. We're in the middle of a massive shift toward renewable energy, and materials are at the heart of that. Whether it's batteries for electric cars, solar panels for homes, or semiconductors for basically all of our tech, the materials we use need to get better, more efficient, longer lasting, you name it. And the faster we can simulate and design these materials, the faster we can make them a reality. Orb is a tool that's going to accelerate that process in a big way. Now, if you're wondering how Orb came to be, it all ties back to this foundation model I mentioned earlier, Linus. The team at Orbital has been training and refining Linus from the ground up. Orb is like Linus on steroids, specifically fine-tuned for advanced material simulations. They've got a whole blog explaining the key elements if you want to dive into the technical side, and they've got even more info coming soon. So yeah, this isn't some random new AI model, it's been a long time coming. And can we just take a second to appreciate the team behind this? This isn't some massive tech giant with endless resources. We're talking about a small, tight-knit group that's competing with the biggest names in AI, Google, Microsoft, and so on. It's proof that even in an era where it seems like only the giants can make big moves, a scrappy, motivated startup can still come out on top. So there you have it. Orb, the fastest and most accurate AI model for advanced material simulations, is out there, and it's free to use for non-commercial purposes. I can't wait to see where this goes.